Our next identities are called product to sum identities. And we're going to start off with the sum and difference identities to see how these are developed. So in the example here, we want to develop the identity for sine of alpha cosine of beta. So we're going to pick the two identities that contain sine alpha cosine beta. So looking up in the identities here, I want sine alpha cosine beta. Well, I see sine alpha cosine beta there. And over here I have sine alpha cosine beta. So I'm going to take those two identities, and down here you can see we've taken those and added them together. So the left side of the equal sign becomes this sine alpha plus beta plus sine alpha minus beta. On the right side, the cosine alpha sine betas drop out, and we're left with 2 sine alpha cosine beta. If we just take that and divide by 2, we're going to get what we want, and that is the formula given here, that the sine of alpha sine of beta is 1/2 cosine alpha minus beta minus cosine alpha plus beta. For cosine alpha cosine beta, we have the 1/2 cosine alpha minus beta plus cosine alpha plus beta. And then we have on the other side here for the sine alpha cosine beta. These formulas are helpful when we want to change a product into a sum. So let's look at how we can apply that. Again, you may have these formulas written down, although it's good to know how to develop them too. So we have the cosine 6x, cosine 3x. So I see that if I can combine that, I can add like terms there. So that's kind of the motivation for wanting to change this to a sum. So my formula tells me that I'm going to take this and rewrite it as 1/2 times the quantity, the cosine of alpha minus beta. So 6x minus 3x plus the cosine of alpha plus beta, 6x plus 3x. Doing a little bit of simplifying, we have 1/2 cosine of 3x plus the cosine of 9x. Nothing really we can do to simplify that, so that is going to be as good as it gets for our answer. Well, they did distribute the 1/2 here, not a significant change. Okay, so try applying the sine cosine product formula to this expression. And the answer is C.